In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work. In the first two problems, or the first example, you were given several polygons to find both the perimeter and the area of. And so in this first one, you're given a rectangle, which is 3 inches by 8 inches. For the perimeter, I need to be able to add up all four sides. So, just kind of noting that this would be 3 inches and 8 inches as well. Or using the formula, you do 2 times the length plus 2 times the width. I mean, whichever way you want to help yourself remember it. But if I would add these four sides together, I would get a total of 22 inches. Now, of course, the area is either length times width, or sometimes in some books it would be just described as base times height as well. So I would do 8 times 3 and get 24 square inches, and that would be the area of this rectangle. Parallelograms are very similar in that I'm still going to find the area by doing base times height. Now, a base could be any side of the parallelogram. So basically, this is a side of the parallelogram, this is a side of the parallelogram. So knowing that this is also 7.5 and this side here is also 14, let me figure out the perimeter, because if I add those together I get 43, which makes that 43 feet. But this is also acting as the base of the parallelogram because I'm drawing a height here that's perpendicular to it. I could have also possibly found a height that's perpendicular to one of these two sides as a base. It would give me the same area. So, and sometimes in geometry courses specifically, you might be given problems where it says, okay, you're given this information, find the height of the parallelogram if 7.5 foot side was treated as a base. But we're not asked to do that here. So for our purposes, this is the height, this is the base, and so the area would be 14 times 6, which is 84 square feet. For this triangle, we're given that the three sides are 6.3, 10, and this side here is actually split up by this height into a 2 centimeter and 8 centimeter piece. So first of all, we have to be aware of the fact that the side of this triangle is in total 10 centimeters. So the perimeter would be 10, 10, and 6.3 added together, which gives me 26.3 centimeters. As far as the area goes, now any one of these three sides could be considered the base. However, in this particular problem, this 10 centimeter side is being considered the base because this height is drawn perpendicular to it. And so when I do the formula, which is, looking at this being the base and the height, 1/2 the base times the height would give me 30 square centimeters for this. Most people don't have a whole lot of difficulty with squares because, all four sides are the same measurement. So if you basically realize that and add all these together, or just realize there's 4 10s being multiplied, I know that the perimeter is 40 millimeters. And of course, the area is going to be length times width, which happen to be the same thing, which is why in a lot of textbooks, sometimes it says that the area is s squared for a square, which means the side measurement squared. Or I just do 10 times 10, treating it like a rectangle because the square is a rectangle as well. I would get 100 square millimeters. And the last one you were given in example 1 was a trapezoid. A trapezoid, it has usually legs. Now, the legs are the non-parallel sides. The bases are the parallel sides. And the height's drawn perpendicular between the two bases. So the perimeter, I would just add up all the sides. So 7 plus 12 plus 11 plus 12. And I would get 42 meters. This is the first base, this is the second base, this is the height. And the formula would be 1/2 the height times the sum of the two bases, which gives me 81 square meters. In example 2, you're given a right triangle to look at. It asks to find a couple of pieces of information. You're asked to find the missing side A. And with that missing side A, you should be able at that point to be able to find the perimeter. And also it's going to help you find the area as well. So now, since this is a right triangle, and only because this is a right triangle, it does obey the Pythagorean theorem. And the Pythagorean theorem says that the two legs squared and added together should equal the hypotenuse squared. Since the 10-inch side is opposite the right angle, this is the hypotenuse. So 8 and a are both legs, which is why I set up the equation looking like this. So a squared plus 64 would equal 100, which means that a squared would equal 36, which means a would be the square root of that, which is 6. So a is 6 inches. Knowing that what that side is now, I can now answer these two questions. The perimeter would be me adding all three sides together. So 10 plus 8 plus 6, which totals to be 24. So the perimeter is 24 inches. As far as the area goes, any one of these three sides could be the base of this right triangle. In right triangles, it makes sense to make one of the legs the base, because if one of the legs of a right triangle is considered to be the base, then the other one has to be the height because of this. So basically, being perpendicular allows me to say that, you know, the two legs are going to form a base height pairing. It doesn't matter which one I call which. For my purpose, I just called A the base and 8 inches the height. And I would do 1/2 the base times the height, or 1/2 6 times 8, and also get 24, but this is 24 square inches. In example 3, you were given two circles to look at, and each one of them you were asked to find the circumference in the area. Now, circumference is basically the same thing as a perimeter is for a polygon. So the circle, for a circle, the circumference is basically the measurement of the entire outside. This 13 millimeters is the radius. I have to be aware of if they're giving me the radius or the diameter, because it's going to affect what value I put into the formulas. For circumference, there are two formulas that are typically given. You have pi times diameter, or 2 pi times the radius. And since I do have the radius here, the circumference is going to be 2 pi times the radius, which is 13, which is 26 pi. And you're asked to leave these in terms of pi, and the pi is already there, so I'm just going to write 26 over here. As far as the area goes, area is pi times the radius squared, which gives me 169 pi, because 13 squared is 169. And again, leaving it in terms of pi means I just put the 169 there. For the other circle, this one you had been given that this diameter is 16 yards. Now that's fine for the circumference, because for the circumference, you know, there's a formula that's pi times the diameter. I can use that for circumference. And so pi times 16, or 16 pi, is the circumference, which means I put a 16 there because the pi is already present. For the area, though, there's only one formula. There's only pi times the radius squared. So knowing that 16 yards is the diameter means that the radius has to be half of that, or 8 yards. And so when I calculate the area now, I'm going to have pi times 8 squared, which gives me 64 pi square yards. So I'm just going to put 64 in there because the pi was already given. In the next example, you're given this rectangle with these 4 circles inside of it, and you're asked to find the area of the shaded regions, the total area of all these shaded regions. Well, as I look at this, there's some information I'm going to need to know, because, I mean, right now for me to find any kind of area whatsoever, I only have one dimension given to me here, but there's some information that I do see here. These 4 circles span this 24 millimeter length, which means that I have 4 diameters essentially equaling the same length as this 24 millimeter side of the rectangle. So I know that 4 diameters is 24 millimeters, which means that the diameter of each one of these circles is 6 millimeters. Knowing that, I also know that, well, if I go from here to here, the height of this side of this rectangle is equal to 1 diameter of a circle, and that's going to mean that the other side of the rectangle is going to be 6 millimeters. Since the diameter of these circles is 6 millimeters, that means that each circle has a radius of 3 millimeters. This gives me the background information I need to come up with the area of the shaded region, because the area of this shaded region is going to be the area of this rectangle I have here minus the combined area of the 4 circles. So it's like me saying I'm going to find this area here, and I'm going to take away the area of these 4 circles, and that's what I'm going to have the shaded region. So the area of the rectangle is pretty easy. I mean, it's just length times width, so it's going to be 24 times 6. The area of each one of these circles is going to be pi times the radius, which is 3 squared. So I have 24 times 6 for the area of the rectangle. Pi times 3 squared is the area of one circle, and since I have 4 of them, I'm multiplying it by 4, and I'm going to carry through the subtraction of those two things. So that gives me 144 minus 36 pi, which is approximately 31 square millimeters. And they want you to round to the nearest square millimeter, so it's 31 square millimeters. For the next one, they wanted you to complete these conversions. How many square yards are in 396 square feet? For this, you have to know your basic conversions, and usually they're not going to ask you anything beyond that's too difficult. Hopefully most of you know how many feet are in a yard, how many inches are in a foot, and even some of the basic metric ones like centimeters, meters, millimeters, how they relate to each other. We know that there are 3 feet in a yard. So when I start with, but I'm going from square feet to square yards, so I have to be careful about how I do this. So I'm going to start with 396 square feet. I know it's 1 yard over 3 feet, but I'm going to square that conversion because I want square yards and square feet. So basically what this all amounts to is that I'm eventually going to take 396 and divide it by 9, or times 1/9, and I'm going to get 44 square yards. Now as far as 14 square feet becoming square inches, I know there are 12 inches in a foot. So I'm going to take 14 square feet. I'm going to put number of feet down at the bottom here because I want to cancel 12 inches on top because I want to become that. But that's 12 inches per foot. I got to square that in order to have inches squared and feet squared involved here. So essentially the result of this is I'm going to have 14 times 12 squared, which is 14 times 144. And that becomes 2016 square inches. Now for 25,600 square centimeters. Well, I know there are 100 centimeters in the meter. So I'm going to use that conversion to assist me here. But again, I have to make sure I have square centimeters and square meters involved. So I'm going to take 25,600 square centimeters. I know there's 1 meter for every 100 centimeters, so this conversion is going to help, but I have to square that conversion in order to get meters squared, what I'm looking for, and centimeters squared, what I currently have, involved together. So as a result of this, I'm going to basically have 25,600 divided by 10,000, and that's going to give me 2.56 square meters. Now I'm going to take that same 25,600 square centimeters, and I'm going to convert it to millimeters squared. Now, I know that there are 100 centimeters in a meter. I know that there's 1,000 millimeters in the meter. So there's basically 10 times as many millimeters as there are centimeters. So basically, 1 centimeter is 10 millimeters. But again, I want square units involved. So when I do the conversion, I'm going to have 10 millimeters on top for every centimeter, but I'm going to square that conversion in order to have millimeters squared and centimeters squared involved in this calculation. And so as a result, I'm going to have 25,600 times 100, which is going to give me 2,560,000 square millimeters. For the last example you're given this situation here where you have this basically this layout of the yard that Jim and Wendy's home is sitting on, and they wish to hire a lawn service to cut their lawn. M&M Lawn Service charges 3 cents per square yard of lawn. So one of the first things to keep in mind here is everything here is dealing with feet, and the areas I would find are in square feet. So I am going to need to do a conversion at some point along the way in order to use this. How much will it cost them to have their lawn cut rounded to the nearest whole dollar? So basically what I have to do is I have to kind of look at this from like, a blank slate first. Their property is 200 feet by 100 feet. And if that property were all grass, that would be what they'd have to take care of. So basically the area of this property is 20,000 square feet. And if the property had nothing on it, the area to mow would be the area of that property. But we know that's not the case. This property has several structures on it that are going to be on top of the grass, and therefore there's no grass that can be cut in those various locations. The first of those is the pool. There's a 24-foot diameter circular swimming pool on the lawn. Obviously, if it's dug into the ground, that grass was gotten rid of. If it's sitting on top of the lawn, you're not going to be able to mow underneath of it. So M&M Service is not going to charge to mow that area. So that area would be pi times 12 squared, because the diameter is 24 feet, that means the radius is 12. And so that's 144 pi square feet that's going to be taken off of this. So I would subtract away the area of the pool as part of this down here. One of the next things that we have on this property is we have the patio that's connected to the house, which will eventually be put in here. The area of that patio, it's a rectangle, it's 40 by 10. It's 400 square feet. So that 400 square feet will also be subtracted away from the area of the property because you can't mow what's there because that lawn has been replaced with the patio. The house, which is 50 by 25 feet rectangle, which gives me an area that sits on the area of the house that sits on the lawn is 1,250 square feet. That has to be subtracted away from the area of the property because I can't mow there either. Same with the driveway. The driveway is 30 by 10, so that's 300 square feet. And it's not going to be able to be mowed there either, so I'm going to subtract away that area. And the last thing is a shed, which is 10 feet by 8 feet. Now, we're not dealing with the heights here because we really don't care. We just want to see how much of the lawn it's taking up. That's 80 square feet. That's going to be taken away from the area of the property. And so basically the area that's going to be mowed is the area of the property minus these other areas along the way. So I got to find out what that area is. So I have all the individual areas, so I'm going to take 20,000 minus 144 pi minus 400 minus 1,250 minus 300 minus 80. And when I do that, I get about 17,516.61066 square feet. I kept all the decimal places that my calculator gave me, so I'm not rounding anything off yet. Next, I got to figure out the cost. Now, the cost that we're given is a rate per square yard. I currently have a value in square feet. So to start figuring out the cost, the first thing I would have to do is convert square feet to square yards. I know there's 1 yard in 3 feet, so if I take that conversion and square it, that's going to cancel the square feet and give me square yards. Now at this point, I would have square yards, so to get a dollar amount, I would take $0.03 or 3 cents over 1 square yard, and that would get rid of the yard squared and give me dollars left over. When I carry out this multiplication, I get about $58.39 When I round that to the nearest whole dollar, that's $58. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.